Hi students, welcome to today's class. Today we are discussing about the encoding of convolutional code by using transform domain representation. Okay, the second method of encoding of convolutional code is transform domain representation. In transform domain, convolutional procedure can be simplified by transforming impulse response as well as message sequence to polynomials. That is, in transform domain representation, convert or transform the impulse responses, that is the message sequence and the generator sequence. There are two sequences. Okay, we can found the code word by using message sequence and generator sequence. So convert this message sequence and generator sequence into polynomials and multiply the two polynomials and convert to binary. So this is how we are finding the code word in transform domain representation. Okay, so convert the generator sequence as polynomial, that is output G1D, that is output G1. The generator sequence corresponding to output 1 is G1 and can be converted into as polynomial, that is G1D is equal to G11 plus, that is constant, plus G2D, G21D plus G31D square plus etc. plus Gm1D n minus 1, because the D starts here at G2. So when G is M, then D raised to m minus 1. Similarly, the output generator sequence can be converted into polynomial as G2D is equal to G12 plus G22D plus G32D square plus etc. plus Gm2 dm minus 1. So in this session we converted the generator. In this session we converted the generator sequence as polynomial. Now we want to convert the message sequence as polynomial. So corresponding message, let message U is the message and the corresponding polynomial is U of D is equal to U1 plus U2D plus U3D square plus etc. plus UK dk minus 1. So this is how we convert the generator sequence and message sequence to polynomial. Then we can find the code word as V1D is equal to UD, that is the message sequence polynomial UD into this generator sequence polynomial, and V2D is equal to message into the second output G2D. So this is how we are finding the code word in transform domain representation. Okay. Now consider the question, let G1 is equal to 111 and G2 is equal to 101 and U, the message U equal to 110110. Then find the code word by using transform domain representation. Okay, now the solution is, first of all we want to convert this sequence to polynomial. Okay, so we have G1 is equal to, so converting this G1 sequence to polynomial, we have G1 is equal to, we have G1, polynomial G1 is equal to, or G1 D is equal to, by converting this we get 1 plus D plus 1 1 1 1. G1 is equal to 1 1 1. So first one is constant 1 plus, second one 1 into D, that is D, plus third one is 1 into D square. So this is how we are writing the polynomial. So G1D is equal to, first one constant 1 plus D square. And similarly we can write, okay, G2 is equal to, G2D is equal to, this is G2, that is 1 plus 0 into D. So the coefficient of D, since the coefficient of D is 0, there will be no D power. Then we have 1 into D square. Then we have 1 plus D square as the polynomial. Similarly, we can find the polynomial U of D as, this is constant 1 plus power of D is 1 plus D square is 0, then D cube plus D raised to 4 plus d raised to 5 is 0. So u of d can be written as 1 plus d cube plus d raised to 4. Okay, now we converted the sequences to polynomial. Then we can find the code word v1 is equal to, that is u of d into g1 of d, and u2 is equal to u of d into g2 of d. So first we want to find v1 of d, that is u of d into g of d. Then u of d, what is u of d? U of d is nothing but, okay, we can write, okay, u of d is nothing but 1 plus d cube plus d raised to 4 into g1 of d is nothing but 1 plus d square. So this is how we get the polynomial. Then by multiplying these two, we will get, that is equal to 1 into all this term. Okay, 1 into this term we get 1 plus d cube plus d raised to 4 plus d into all this term. So 1 into d is d plus d into d is d square plus d into d cube is d raised to 4 plus d into d raised to 4 will be d raised to 5 plus d square into all this term we get 1 into d square will be d square plus d into d square will have d cube, then d square into d cube will have d raised to d square to d cube, d raised to 5. We are adding the powers, right? Then d into d square into d raised to 4, that is d raised to 6. Okay, this is modulo 2 addition. So we have 1 plus, we have 2 d's, so d plus d will become 0. Then d square, okay, d square plus d square will be 0, d cube plus d cube will be 0, d raised to 4 plus d raised to 4 will be 0, d raised to 5 plus d raised to 5 will be 0. Then we'll have d raised to 6 here. So 1 plus d raised to 6. This is the polynomial 1 plus d raised to 6. Now, so the binary corresponding to v1 we can write as 1 plus d raised to 6. So the binary corresponding to v1 as constant is here, that is 1. Then we have power of d square, d cube, d raised to 4, d raised to 5. These all are 0. So we can write 5 zeros, 1, 2, 3, 4, 5. Then we have d raised to 6, then 1. So this is the binary of v1. Similarly, we want to find v2. Now v2 is equal to, okay, v2d is equal to, that is, this is v1d, v2d is equal to u of d into g2d, okay, which is equal to u of d we have 1 plus d cube plus d raised to 4 into g2d. So we have g2d as 1 plus d square, right? 1 plus d square. Now by multiplying these two we get 1 into this term will get 1 plus d cube plus d raised to 4 plus d square into all this term. 1 into d square will be d square plus d square into d will be d cube plus d square into d cube will be d raised to 5 plus d square into d raised to 4 will be d raised to 6. Then we have 1 plus d. We have 1 d here, so we can write d as such plus d square. We have 1 d square, so we can write d square. D cube. We have 2 d cube, so we can drop that. d raised to 4, you can write d raised to 4 plus d raised to 5 plus d raised to 6. These all we are doing modular 2 addition. So in modular 2 addition, if there is similar value, then it will become 0. Dissimilar value, it will be 1. Okay, so 1 plus d square plus d raised to 4 plus d raised to 5 plus d raised to 6. Similarly, we can write the corresponding binary. This is the output. Corresponding binary v2 is equal to, we have constant here 1. Then we are looking power of d is 1, power of d square is 1, power of d cube, there is no power of d cube, so we can write 0, power of d raised to 4 1, power of d raised to 5 1, power of d raised to 6 is 1. So this is the value of v2, that is 1 1 1 0 1 1 1. Now by combining the v1 and v2, we can write the v output as v is equal to the first term of 1, first term of v2, therefore 1 1 1 1 0 1, then this will be 0 1 0 0 0 1 0 1 1 1. So this is the code word. V is equal to 1 1 0 1 0 1 0 0 0 1 0 1 1 1. So this is how we are finding the code word. The code word is finding first term of v1, second term of v2, v2, second term of v1, second term of v2. Similarly, we are finding the v code word. So this is how we are finding the code word in transform domain representation. Okay, thank you.